Hi! Our lesson for today is all about the formation of light elements in the beginning of the universe. Let's begin. Here are the things that we should learn by the end of this lesson. First, define the Big Bang nucleosynthesis. Second, identify the mechanisms of Big Bang nucleosynthesis. Third, explain the formation of light elements in the beginning of the universe through the Big Bang nucleosynthesis. The Big Bang model is the most prevailing model of the origin of the universe. It describes how the universe began in a rapid expansion of 13.7 billion years ago. It offers explanation to a broad range of phenomena, including the formation of light elements. In 1948, Alfred and Beth and Gamow published a paper entitled The Origin of the Chemical Elements. They describe a process by which all of these elements in the universe could have been formed shortly after the Big Bang. Big Bang nucleosynthesis refers to the production of light elements, specifically the normal hydrogen and other isotopes, shortly after the Big Bang. The Big Bang nucleosynthesis is believed to be responsible for the formation of hydrogen, deuterium, helium isotopes, lithium isotope, and other amounts of beryllium. We have here the mechanism of Big Bang nucleosynthesis timeline, in which you can see that the period of nucleosynthesis lasted only from about 10 seconds and to about 20 minutes from the beginning of the universe itself. The temperature in the early universe was extremely high, that fusion reaction could take place. These fusion reactions, however, are slightly different from the fusion reactions in the interior of the stars. Thus, as the universe expanded and cooled, no more neutrons were formed. Once the production of neutrons stopped, their ratio relative to the stable protons started to decline. When the universe further cooled, the number of protons outnumbered the number of neutrons. Also, at this lower temperature, neutrons were able to combine with protons to form the isotopes of hydrogen and deuterium. The deuterium nuclei is very reactive. For several minutes, the deuterium nuclei went through a variety of nuclear reaction, resulting to a mixture of isotopes. So we have here the He3, the He4, and the Li7, along with the primordial H1 and H2. So we have here the mechanism of the Big Bang nucleosynthesis, also known as partial fusion reaction. So this illustration illustrates two of the nuclear reactions which occur during the Big Bang nucleosynthesis. It shows protons and neutrons combining to form deuterium nuclei. As you can see here, it denotes as letter D, containing one proton and one neutron, accompanied by the emission of high-energy photons or in the form of gamma rays. Furthermore, it shows two deuterium fusing to produce one nucleus of helium-3 with one neutron with two protons and one free neutron. After the Big Bang nucleosynthesis, the universe expanded outwards and cooled. As the temperature of the universe lowered rapidly, the densities of particles decreased. A decrease in density means that the likelihood of particles colliding will decrease too. Nuclear fusion stopped. The expanding universe had been an optically opaque plasma of photons, free electrons, and primitive elements. The universe became optically clear when neutral atoms were formed through the combination of electrons with atomic nuclei. As you can see here, a periodic table, also known as astronomical periodic table, which indicate the origin of elements. So here, as you can see in the legends, it has different colors, and different color signify a certain formation. So we have here the dark violet. So dark violet, here the hydrogen and helium gas, they are formed from Big Bang nucleosynthesis. And we have the Li, the Be, the lithium, beryllium, and boron. They are formed from the cosmic rays. And for the yellow green, we have sodium, magnesium, potassium, calcium, and so on. All those elements in the periodic table with green color, they are formed from large stars. And for the brown, so we have rubidium, cesium, francium, radium, and so on. Those elements with brown color, they are formed from supernova. And for the elements with yellow-green color, so we have some of the carbon, some of the nitrogen, some of oxygen, some of neon and sulfur. They are formed from small stars. And those elements with violet color, as you can see below, so they are formed from laboratory because they are man-made. Always remember that Big Bang nucleosynthesis describes the formation of light elements shortly after the Big Bang. It is believed to be responsible in the formation of hydrogen, deuterium, helium isotopes, lithium isotopes, and trace amounts of beryllium. So, nuclear fusion, it is a process where two or more nuclei combine to form a new element. Governs the nucleosynthesis process. So as you can see a while ago, the image of He3 and one free neutron, they are performed they performed the nuclear fusion process. Due to high temperature, the fusion process became possible, resulting to the combination of protons and electrons to form neutrons and so on. This is the end of the presentation. I hope you learned something. Thank you.